Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire syllabus of IGCSE Cambridge Chemistry. The course code is 0620. And in this lesson, we will be covering 6.4 Redox, both the core and supplement topics. So I also offer one-on-one tutoring lessons. If you need help, you can fill out the Google form that is given in the description. And you can also join my community. It's for free. You can join it for free. It's called High School Chemistry on school.com. The link is given in the description. So in that community, I offer a free lesson once a month, and there are also premium packages which you can purchase, where I offer 4 lessons in a month, one lesson per week. And in the free package, you can ask questions, participate in the discussion forums, interact with other students from all around the world. Okay, so now we come back to topic 1. Use a Roman numeral to indicate the oxidation number of an element in a compound. So what is oxidation number? Oxidation number is basically a number that is assigned to a metal and a non-metal based on how many electrons it has gained or lost while forming a certain compound. So we use a Roman numeral specifically for transition metals. So if this is if this is a periodic table, like this is group 1 and group 2, and this is group 3, from group 3 to group 8. So these elements that are found between group 2 and group 3, they are called transition metals, right? So whenever we write compounds belonging to transition metals, we often write that they are, we mention the Roman numeral or the oxidation number. Why? Because they have a variable oxidation state. For example, let's say copper, right? So copper exists in Cu plus form and Cu2 plus form. So and other metals that are like non-transition metals, they always lose a certain number of electrons, right? Or they gain certain number of electrons if it's a non-metal. So, but transition metals, they can sometimes, like let's take a look at copper. Copper can lose 1 electron depending on the reaction conditions, and sometimes it may lose 2 electrons. So when copper has to combine with chlorine, so if it's copper 1 plus, so the compound will be CuCl, because chlorine is always -1, right? Like in most cases, on this level of the IGCSE Cambridge Chemistry, we say that chlorine is -1, right? So and for copper 2, if it copper 2 has to combine with chlorine or chloride ion, so the formula will be CuCl2. We have discussed this in our previous lessons, like the crisscross method. So if you don't understand that how do we write ionic, the formulas of the ionic compounds, you can go back and watch that video and then come back and continue learning this lesson, like this topic. So now, if I say copper chloride, right? So now, okay, let me just write here, copper chloride. Now, it doesn't mention, like, I don't know whether I'm referring to CuCl2 or CuCl, right? So this is why, for transition metals, just because they have a variable oxidation state, they can form ions with different charges. So that is why it is important to mention, that what is the oxidation state of a certain metal in its compound. So if I have to write the name of this one, CuCl2, so I will write copper, and then in parenthesis Roman numeral 2, and then chloride, right? And this is copper 1, Cu1 plus, so this will be copper 1 chloride, right? So I hope this is clear. Other examples are like iron oxide. So iron oxide, iron also exists in like from with the different variable or variable oxidation state. Iron exists as 2 plus, iron can exist as 3 plus, right? So if this iron has to make a bond with oxygen, the oxygen is always 2 minus, at this level, and yeah, so Fe2 plus. So we will write, FeO. So this is iron 2 oxide, right? Iron 2 oxide, and this one, the formula will be Fe2O3, and this is iron 3 oxide, right? Yeah. So, and if they give you the formula and they ask you that what is the oxidation state of iron, so knowing that oxygen is -2, and a compound has to be neutral, we can figure out that iron will be +2, right? So we will cover this in more detail in our upcoming topics in the same lesson. So keep watching. And at the end of this lesson, we will also practice some questions from the past papers, and it will become very clear. Like all the concepts, I'm sure they will be very clear by the end of this lesson. Okay, so now we move on to topic 2. Okay, let me just read it one more time to make sure that I'm not, missing or skipping anything. So use a Roman numeral to indicate the oxidation number of an element in a compound. Yeah, so the oxidation number of an element is the charge of an element or ion in a compound, which relates to the electrons gained or lost by the element or ion during the formation of the compound, right? So that's the definition. So now we move on to the next topic, which says that define redox reactions as involving simultaneous oxidation and reduction. Yeah. So what is redox? What are redox reactions? Redox reactions are reactions where oxidation and reduction uh, occurs simultaneously. We don't know what is meant by oxidation and what is meant by reduction yet, but we are trying to establish that we are trying to understand that what are redox reactions. Whatever these processes are, oxidation and reduction, in a redox reaction they occur simultaneously, right? In the same reaction, oxidation will be taking place and reduction will be taking place as well, right? So such reactions are called redox reactions. And all reactions, I mean, if in a reaction oxidation is taking place, so reduction will be taking place at the same time, right? So it is not possible that in a reaction only oxidation is taking place and reduction doesn't take place. That cannot happen. So any reaction in which oxidation occurs, reduction will occur simultaneously, and such reactions are called redox reactions, right? So I hope this is clear. Now, in the third topic, we try to understand that what is oxidation and what is reduction, right? So define oxidation as gain of oxygen and reduction as loss of oxygen, right? Okay, so this is another topic. Let me just separate this one. Hold on. Okay. So, yeah, now let us take a look at this. Define oxidation as gain of oxygen and reduction as loss of oxygen. Yes. So, oxidation means whenever an element or a compound gains oxygen, right? Let me explain. So, for example, uh, you know, Mg plus O2, magnesium, when it reacts with oxygen, it produces magnesium oxide, right? So now you can see that oxygen got added to magnesium here, right? So we say that magnesium has been oxidized. So this is oxidation, addition of oxygen. Now reduction is the exact opposite. And now let's say if copper oxide, this is copper 2 oxide, because oxygen is negative too. Don't worry, we will understand it in our next topic, upcoming topic. So copper or copper 2 oxide, when reacts with hydrogen gas, it changes into copper plus H2O. So now you can see that copper on the reactant side, it was connected to oxygen, and but on the product side, it is without oxygen, right? So we can say that copper has been reduced. So this is reduction. So now let's go back to topic number 2, which says that define redox reactions as involving simultaneous oxidation and reduction. So you may be thinking that why I have written only oxidation in front of this reaction. If it's a redox reaction, if oxidation is taking place, a reduction must also be taking place in this reaction, in reaction A. And in B, if I have written reduction, so according to topic number 2, there must also be oxidation taking place. Yes, you are absolutely right. So it is all about perspective. Now, I explained this reaction from the perspective of magnesium. Magnesium is being oxidized, but now look at oxygen. In oxygen, on the reactant side, let me balance this equation. So I'll put 2 here and 2 here. The equation is balanced. And yeah, the second equation, it is already balanced. So yeah, so you can see that magnesium, it is without oxygen on the left side, and it is with oxygen on the right side. So I can say that magnesium is oxidized, right? And now look at oxygen. So oxygen on the reactant side, it was O2, 2 atoms of oxygen. But on the product side, we have only 1 oxygen connected to magnesium, right? So oxygen, got reduced. Oxygen lost, oxygen molecule lost, and 1 oxygen atom. So I can say that oxygen is reduced, right? So now, like, it is not contradicting this topic that we discussed above. Both these reactions are redox reactions because oxidation and reduction is taking place simultaneously. But just for the sake of understanding, I was explaining with respect to magnesium and with respect to copper. So now look at this reaction. You can pause this video and try to figure out that how or which atom is being oxidized, right? So yeah, hydrogen is being oxidized. You can see here that hydrogen is without oxygen on the left side, and after the reaction, now oxygen is added to hydrogen. So we can say that hydrogen is reduced, I mean is oxidized, and copper is reduced. So Cu is reduced, right? Yeah. So this is how we develop our understanding, but this understanding is only for core students. I mean, also for extended students, but oxidation and reduction is a lot more than gaining or losing electrons. But those concepts, therefore, extended students in supplement topics, right? So those students who have registered for core, they will not be assessed related to the other definitions of oxidation and reduction. So now we move on to topic number 4, which is for core and extended both, or supplement. So identify redox reactions as reactions involving gain and loss of oxygen. Oh, yeah. So identify redox reactions as reactions involving gain and loss of oxygen. Yeah. So the same thing we discussed here, right? But now I can give you guys another example. For example, H2 plus zinc oxide, it is changing into zinc and H2O, right? And yeah, now you can pause this video and try to figure out that which element is being oxidized and which one is being reduced. Okay, so now I'm about to explain the answer. So here you can see that hydrogen is without oxygen, and after the reaction, hydrogen is with oxygen. So we can say that hydrogen has gained oxygen, so hydrogen is being oxidized, right? And zinc, it has oxygen connected to it on the reactant side, and zinc is without oxygen on the product side. So I'll say that zinc is being reduced, has been reduced, right? Okay, so I hope this is clear. Now we move on to the next topic, which is topic number 5: identify oxidation and reduction uh, in redox reactions. Well, I think we are doing the same thing since topic number 3, but they really like to oversimplify the topics. But anyways, okay, let's try. Let me write this reaction: Fe2O3 plus 3CO, that is changing into 2 iron atoms plus 3 carbon dioxide. So that's the balanced equation, right? So now in this equation, try to figure out that what is being oxidized and what is being reduced. So here we can see that iron is with oxygen, and here iron is without oxygen. So iron is being reduced, iron is reduced, and carbon dioxide, you can see here that carbon monoxide. So carbon monoxide, it has 1 oxygen atom, but on the right side, on the product side, it has 2 oxygen atoms. So we will say that carbon monoxide has been oxidized. So very simple. You just have to focus on which element or which compound is losing or gaining oxygen. So you have to compare the reactant with the products, right? And you will figure out that what is being oxidized and what is being reduced. Super duper easy. Okay, so question number 6. Okay, so now this is uh, for extended or supplement topic, right? This is not for core. So okay, let's so core students, like you can stop here, and but because the remaining topics, they are for extended students, you will not be assessed on this concept. Okay, so but if you wish to develop your general understandings, but so you can, but if you're sure that it will not may cause you any confusion, only then you should continue watching, otherwise you should stop watching this video. Okay, so question number 6: define oxidation in terms of A, loss of electrons, B, an increase in oxidation number. Okay, so as I mentioned before, that oxidation and reduction is a lot more than only gaining or losing oxygen. So in terms of loss of electrons, so when any element loses electrons, so we say that it has been oxidized. So oxidation is loss of electron, right? Or electrons, and reduction, it is the gain of electrons, right? So I hope this is clear. Let me give you a few examples, but I think they will explain in the upcoming topic that like examples will be included. Okay, anyways, define oxidation in terms of loss of electron and an increase in the oxidation number. Okay, I'm combining 6 and 7 because it says define reduction in terms of gain of electrons, right? So what is meant by an increase in oxidation number? So you see, copper, for example, in a solid state, in a neutral state, it changes into copper 1 plus, or copper plus, right? We usually write just positive. We don't write the number if it's some a +1 or -1. So +1e negative. So you can see that it lost an electron, and its oxidation number, uh, it went from 0 to +1. Remember that oxidation number of metals when they are in a free state, it's 0. For example, like Na, O2, F2, right? Cl2, N2, lithium, potassium, rubidium. So all these elements, they are in their free states. And if they appear in a chemical reaction in their free state, so their oxidation numbers will be zero. Their oxidation number will be zero. So I think we will cover this in our upcoming topic, but since it is necessary to mention this here, so to understand that an increase in oxidation number. So whenever electrons are lost, so it is obvious that the element, that the metal will get a positive charge, right? So now let's say if we start from Cu plus and it loses another electron, so this will become Cu2 plus, right? So you can see that again, there is an increase in the oxidation number. So this is what we mean by oxidation. It can be defined with respect to the loss of electrons, and it can also be defined with respect to the increase in oxidation numbers. So I hope this is clear. We move on to the next one. Yeah, reduction in terms of gain of electrons or a decrease in the oxidation number. Now look here. So let's say we have aluminum 3 plus, and it gains 3 electrons, right? So it's going to change into neutral aluminum, right? So here, for the oxidation number for a monovalent ion is equals to the charge of that ion. So aluminum is in the form of 3 plus. So the oxidation number of aluminum here on the reactant side is 3 plus, right? So when it gains 3 electrons, it changes into its free state, into its neutral state, where oxidation number is 0. We have already talked about it here. So now you see, gaining of electrons is reduction, and during this process there will be a decrease in the oxidation number. So aluminum, it changed from +3 to 0, so the oxidation number decreased, right? So another example will be Cl plus E negative, it changes into Cl negative, right? So it gained an electron, right? So here, chlorine is in the form of, in its elemental states, oxidation number is 0. And after it gained electron, you can see that it changed into, the oxidation number changed into negative, right? So, and it decreased. So from 0, it changed to -1. So this is how we define reduction. And that reduction, whenever an element gains electrons, that is also reduction. And as it gains electrons, its oxidation number decreases. I hope this is clear. We move on to the next part. Topic number 8, identify redox reactions as involving gain and loss of electrons, right? Okay, so yeah, so look here, we have this reaction Cl2 plus 2 potassium iodide. It is changing into 2 moles of KCl plus I2, right? Okay, so now you can see here that chlorine, its oxidation number is 0, because we know that oxidation number of elements in their free state is 0. So chlorine here is in its free state, Cl2. So and potassium iodide. Okay, so now we need to figure out that what will be the oxidation number of potassium and iodine in potassium iodide. So remember that group 1 metals, they have they always have the oxidation state of +1. And group 7 metals, non-metals, group 7 non-metals, they have the oxidation number of -1, right? So since iodine is from group 7, so sodium is plus, potassium is +1. Let me just write their oxidation states. Potassium is +1 because it loses 1 electron, and since iodine is in group 7, it has 7 electrons in the outer shell, and it needs 1 to have a complete outer shell. So it will be -1. On this side, potassium is +1. Chlorine, being from group 7, it is -1. And this is iodine in a free state, so it's 0. So now let's compare that which element got oxidized and which got reduced. So chlorine, there's a change in the oxidation state of chlorine. So chlorine, went from 0 to -1, right? And you can see that there's a decrease in the oxidation number. So it means that it is a reduction. So we can say that chlorine, right, got reduced, right? Because chlorine has gained electron. Chlorine has gained electron. Okay. So similarly, for if you look at iodine, so in potassium iodide, it is -1, and from -1, it is changing into 0, right? So that is an increase in the oxidation number, and that happens when electrons are lost. So here we can say that, so I can write the ionic equation or the half equation. So 2I negative, it is changing into I2 plus 2E negative, right? So I will say that iodide ions have lost electrons, and this is or we can say that iodine got oxidized, right? Okay, so I hope this is clear. And yeah, we move on to the next one, which states that identify redox reactions by changes in the oxidation number, using the oxidation number of elements in their uncombined state. um, yeah, is 0, and the oxidation number of a monoatomic. Yeah, so now they are they want us to explain the rules, right? So let us take a look at the rules. And okay, so this is very important to understand this entire topic, right? So it should be the first topic, but like they have added it here. So let's try to understand. So the first rule is that the oxidation number of elements in their uncombined state is 0. We have already talked about this. So the oxidation number of zinc, if it is in a free state, so it is 0, right? So chlorine is 0 if it is found as a Cl2 in a chemical reaction like this one here, right? And another example is H2. So if hydrogen appears like this in a chemical reaction, for example, H2 plus O2 changes into H2O, and yeah, so here oxidation state of hydrogen, both the hydrogen and the oxygens, is 0 because they are in their free state, uncombined states, right? And yeah, and now the oxidation number of a monoatomic ion is the same as the charge. Yeah, so if you see like 3 plus in an equation, it reacting with something, right? So it's a monoatomic, it is not combined. Aluminum is not combined with any other element, and it has a charge. It's a cation. So the charge, so the oxidation number of this monatomic ion will be +3, right? Because it's that's the rule. Now for example, Cl negative oxidation state is -1, and nitrogen 3 negative oxidation number is -3. O2 negative oxidation number of this ion is 2 negative. Yeah, so very simple. And the third one is the sum of the oxidation numbers in a compound is 0. That is the most important rule in figuring out the oxidation number of the other element. If the if the oxidation number of a certain element, for example NaCl, right? So we know that sodium, it is in group 1, so it will be +1. And so chlorine, only one chlorine is attached, so it will be -1, right? So I hope this is clear. So again, uh, aluminum oxide, for example, so Al2O3. So what will be the oxidation number of aluminum? Aluminum, it is in group 3, so it will always be +3. So here aluminum is in the oxidation state of 3 plus, and oxygen, since it belongs to group 6, so the oxidation number of oxygen will be -2, right? So the sum of the oxidation numbers in an ion is equal to the charge on the ion. Yeah. So for example, if we have SO4 2 negative, right? So what will be the oxidation state of sulfur in this ion? So the sum will be +2. So as sulfur, the oxidation number we don't know, so I write X, plus oxygen, it is in group 6, so it is always -2, so I write -2, but we have 4 oxygen atoms, so I'm going to multiply that by 4. I'll get -8. So X plus -8 must be equals to -2, right? This is what it means. The sum of the oxidation numbers in an ion is equal to the charge on the ion, right? So this will be, um, you know, so yeah, so +6, right? So +6 plus -8, you get, -2. So the oxidation number or the oxidation state of sulfur in SO42 negative is +6. So this is how you figure out the, uh, you know, uh, oxidation number of ions, right? Like polyatomic ions. So now we move on to the next one. Identify redox reactions by the color changes. Yeah, so this is a memory-based topic. You have to memorize the color change. Sometimes when atoms, especially transition metals, when they lose or gain electrons, and their solutions, they change colors, and that color change is used to figure out, becomes an indicator of identifying whether a certain element is being oxidized or reduced, right? So let us take a look at this. Um, yeah, just give me a second. Yeah, so identify redox reactions by the color changes involved when using acidified aqueous potassium manganate. Okay, so aqueous potassium manganate 7, right? So the oxidation number of manganate is +7 here. So Mn is in the state of 7 plus, right? So in its 7 plus oxidation state, manganese has a purple color. It exists in a purple color, right? And when you see, when it changes, it is reduced. It gains electrons, and it becomes two positive. So how many electrons it gained? 5, right? It gained 5 electrons, and the oxidation number decreased from +7 to +2, right? So now this ion will have a different color, and 2 plus is colorless, right? So remember that. So identify redox reactions by color changes involved when using acidified aqueous potassium manganate 7 or aqueous potassium iodide, right? So for potassium iodide, uh, let me explain the color change. So potassium iodide is Ki. So here, potassium exists in the oxidation state of +1, and iodide ion exists in the oxidation state of -1, right? So when it's gonna lose this electron, I negative, you know, 2I negative, changing into I2 plus 2E negative after losing two ions of iodide. When they lose 2 electrons, so they form, elemental iodide molecule, iodine molecule in a free state, right? So this is colorless, and this has a brown color, right? So whenever I negative change is reduced, is oxidized, so this change will be accompanied by a color change from colorless to brown, right? So I hope and this is clear. So you have to remember that these two color changes, Mn7 plus is purple, and and Mn2 plus is colorless, and the other one, iodine, iodide ion is colorless, and its oxidized form is brown, right? So remember this. Okay, so I hope this is clear. Now we move on to the next part. Define an oxidizing agent as a substance that oxidizes another substance and is itself reduced. Okay, so we need to understand, we need to compare two reactions, right? So let me explain. So basically, an oxidizing agent is a species which brings about oxidation by gaining electrons from other elements. For example, uh, you know, Br2, right? When it is gaining, it gains electrons. So Br negative, right? So Br bromine, it has the oxidation number of 0 on this side, right? And here it is -1 because that's the charge. It's a monoatomic ion. So we can clearly see that it got reduced. It gained electrons, right? So it took this electron from something, right? From another element. So bromine helped that other species to become oxidized, right? So we call this an oxidizing agent, right? So oxidizing agent. Why? Because it is reducing itself and helping the other species to become oxidized, to lose electrons, right? Let's say if we have A and B, right? So uh, let's say B wants to lose electrons, so A must gain that electron, right? So, and to allow B to reduce to lose it, right? So if so A by gaining that electron will help B to become oxidized, right? So in this case we say that A is a is an oxidizing agent because it is reducing itself and it is helping B to lose electrons, and it is helping B to oxidize itself. So I hope this is clear. Now the same thing, define a reducing agent as a substance that reduces another substance and is itself oxidized. Okay, so for example, potassium, right? So potassium, if it gains an electron, right? So it must have gained it. It has lost an electron, right? So this electron must be gained by the other species, right? So potassium, in other words, helping that other substance to be reduced, right? To reduce itself. So potassium, by oxidizing itself, helping the other substance to gain that electron, that is reduction. So here we can say that potassium is a reducing agent. Why? Because potassium is losing electron, it is oxidizing itself so that the other species can gain this electron and reduce itself. So this is how they are connected, and I hope this is clear. Identify oxidizing and agents and reducing agents in a redox reaction. Okay, yeah, so now when we practice this, this will become more clear. So yeah, so now let me write this equation: Cl2 plus 2Ki changing into 2KCl plus I2. Right now, let's see what is happening here. Chlorine, it is in its elemental state, in a free state, so the oxidation number is 0. Now, potassium iodide, potassium is +1 because it is from group 1. Iodide, it is from group 7, it is -1. Potassium +1, chloride -1, iodine 0, because in it's again, it is in its elemental state, right? Okay, now let's see what is happening. Chlorine changed from 0 to Cl negative, right? So we can see that it gained electron, right? So let me write the half equation. So Cl2 plus 2E negative, it is changing into 2Cl negative. So chlorine is gaining electrons and it is being reduced, right? So that's reduction. So anything that undergoes reduction will be the oxidizing agent. Remember that. Oxidizing agent, right? Because it is helping the other species to lose electrons, and by gaining that electron that is lost by that other species, it is playing a role of oxidizing agent. So now let's take a look at iodine here. So iodine, 2I negative, I'm writing the half equation. So it is changing into I2 plus 2E minus, right? So here, this is oxidation, loss of electron, right? And here we can see that uh, why this is being oxidized, because chlorine has the ability to gain that electron, right? So this is iodine is helping uh, chlorine to reduce itself. So this will be the reducing agent. So I hope this is clear. So remember that anything that loses electrons, is the reducing agent, and anything that gains electrons is the oxidizing agent, right? And so I think that is all for this lesson. And I would like to remind you guys again that if you need one-on-one tutoring sessions with me, you can fill out the Google form that is given in the description, or you can join my school community, my community on school.com, with the name of High School Chemistry. So I offer, free lesson once in a month, and I also offer 4 lessons per month, once per week. But that is a premium package which you will have to purchase, but it is super duper economical, and you should not miss that opportunity. So if you have any questions, you can leave them in the comment below. I'll see you guys in the next one. Take care. Goodbye.